Alright, so you've got the periodic table of the elements. Exciting, huh? Not really. I know that when most of you look at this, what you're really thinking is, ugh, what a frickin' headache. But don't worry, this monster's about to get a lot easier to handle. The first thing to know about the periodic table is what each of the pieces on each of the blocks means. Each block on the periodic table represents a different element. Each element is different than the others based on the number of protons it has in its nucleus. This is the number that is shown in the upper part of each block. The large letters in each block are the atomic symbol, or abbreviation for the name of each element. The number at the bottom of each block is the atomic mass of the element. This is a very important number for use in calculations. The group number, shown at the top of each column, divides the elements into 18 different families, each with similar atomic traits. A second group number is also shown above each column of elements. These are the numbers that are used most commonly when referring to groups. The elements of the periodic table are often grouped according to their nature. The group on the right contains all the inert elements, also known as noble gases. To the left of these are the halogens. Left of those, in a step-like pattern, are the nonmetals, which also include hydrogen on the left of the table. Below hydrogen, in the first column, are the alkali metals. To the right of those are the alkali earth metals. All of the elements in the B group are considered transition metals, including the rare earth metals. The elements that complete the right portion of the table are simply called other metals. Many periodic trends, or the tendencies of elements to express certain characteristics, can be observed on the periodic table. These trends include atomic radius, ionization energy, electron affinity, and metallic character. The atomic radius of an atom is the distance from the nucleus to the outermost electron shell. As one might expect, the greater the number of protons and the greater the number of electrons, the larger the atomic radius will be. The atomic radii of atoms increases as you move down and to the left on the periodic table. The ionization energy of an atom is the minimum amount of energy required to remove one electron. Generally speaking, the lower the atomic number, the higher the ionization energy. The observed trend is that the ionization energy of an element increases as you go up and to the right on the periodic table. Electron affinity is the energy gained by an atom when it gains an electron to form an anion. Another way to think of this is the energy required to remove an electron from a singly charged anion. Atoms with fewer protons have higher electron affinity. The trend can be observed that electron affinity increases up and to the right on the periodic table. Electronegativity is the ability of an atom to attract electrons to itself. Noble gases aside, the atoms on the right side of the periodic table are close to filling their valence shells and thus have high electronegativity in comparison with those on the left. The trend in electronegativity is that, in general, it increases the farther up and to the right an element is on the periodic table. The metallic character of an element is the tendency for an atom to lose an electron instead of gain electrons in order to fill its valence shell. As you noticed in the group classification of the elements, the less metallic atoms are on the right side of the periodic table. With this in mind, the trend can be observed that the metallic character of an element increases as you move down and to the left on the periodic table. Now that you know your stuff, don't let this big messy table give you a headache. Just relax, remember the trends, and you'll be fine.